Welcome back to Causal Loop Cosmology, the search for the primitive. In our last episode, we followed Democritus, the laughing philosopher, who imagined a world of atoms dancing in the infinite void. He gave us the actors and the stage of existence, particles and emptiness. But his mechanical cosmos, for all its elegance, lacked something vital: purpose, continuity, meaning. Not everyone could accept a universe made of cold collisions. And so, the next great thinkers stepped forward, not to destroy his vision, but to reimagine the very stage on which reality unfolds. Today, we meet two titans who defined that stage for over 2 millennia. Aristotle, the philosopher of purpose and substance, and Euclid, the geometer of perfect space. One filled the cosmos with striving elements. The other gave it shape with unyielding logic. Together, they built the classical foundation, the world of form and order that would define human thought until the dawn of modern science. Let us begin where we left off, with Democritus's radical vision. Atoms in motion, colliding endlessly through the void. A universe without design, without direction. Everything that exists, he said, arises by necessity, no gods, no destiny, only the ceaseless play of matter. To many of his contemporaries, this vision felt almost heretical. Where was purpose? Where was life? The atomist stripped the world of its soul, turning nature into mechanism. In the city-states of Greece, this view clashed with older, more organic intuitions, that the cosmos was not a machine, but a living harmony. Out of that tension came Aristotle, the Stagirite, who would restore motion, meaning, and hierarchy to the universe. Aristotle was born in 384 BC, in Stagira, a small town in northern Greece. The son of a physician, trained under Plato, and tutor to Alexander the Great, his mind sought not abstraction, but order within experience. He was a collector, an observer, a system builder. Where Plato gazed toward perfect ideals, Aristotle looked outward, to the natural world. He saw leaves reaching for sunlight, flames rising toward the heavens, stones falling to earth. Patterns of purpose, not randomness. From these patterns he constructed a cosmos that was alive, a universe filled, not empty, ordered, not accidental. He rejected the void entirely. Nothingness, he argued, cannot exist. Nature abhors a vacuum. Every space, every region, must be filled with substance. The world was not scattered atoms in a sea of emptiness. It was a continuous plenum, a great living whole, brimming with matter and motion. At the core of Aristotle's physics were the four elements: earth, water, air, and fire. Each element was defined by its qualities, not its shape or size. Earth, cold and dry, heavy and grounded. Water, cold and wet, fluid and receptive. Air, hot and wet, light and expansive. Fire, hot and dry, luminous and consuming. They were not static substances, but transformative essences. Water could evaporate into air, air could ignite into fire, and fire could fall back into ash, earth again. Nature was a web of transformations, a cycle of becoming. And above these earthly layers, Aristotle added a fifth and higher element, the aether, or quintessence, pure, unchanging, eternal. The heavens, he said, were not made of fire or air, but of this divine substance. It filled the celestial spheres, carrying the sun, the moon, and the stars in perfect, unending motion. The result was a hierarchical cosmos, dense and mortal below, pure and divine above. From the center of the earth to the fixed stars, all things found their place in a grand, concentric harmony. But Aristotle went further. He gave motion itself a purpose. For Democritus, atoms moved without reason, bouncing through void like dust in a sunbeam. For Aristotle, motion was never aimless. Every element had a natural motion, a drive to reach its proper place. Earth and water, being heavy, sought the center, falling downward, forming the solid and liquid world. Air and fire, being light, rose upward, toward the heavenly realm. Picture it: a stone dropped in air descends, a bubble of air in water rises, a flame leaps toward the sky. Each obeys its essence, its inner nature. Even when forced from its place, when thrown or displaced, it strives to return. This was the difference between natural and violent motion. Violent motion ends, natural motion fulfills. In this vision, the universe becomes not a battlefield of collisions, but a living order of purposes, a great cosmic sorting. Everything has a direction, a meaning, a goal. Even the heavens, though eternal, move in perfect circles, expressing the divine intellect, the unmoved mover, whose thought sets the cosmos turning. The Earth stood still at the center, heavy with purpose, while the crystalline spheres of the heavens revolved in majestic order around it. It was a geocentric cosmos, closed, finite, but complete. A world of stability and meaning. Why did Aristotle reject atomism so completely? Because, to him, it failed to explain qualities: the warmth of fire, the wetness of water, the life of a seed. Atoms could collide, yes, but how could motion alone create living form or sensation? Democritus's universe was a skeleton, Aristotle's was flesh. The atomist's void offered no explanation for the richness of being. By contrast, Aristotle's four elements, bound by their opposing qualities, generated the diversity of the world. Change arose from tension, balance, and transformation, a cosmos that mirrored the harmony of body, soul, and society. In his system, physics and metaphysics merged. Every natural thing sought fulfillment, its telos, or purpose. A seed grows into a tree not by chance, but because that is its essence. A planet moves in circles because circular motion is divine. Even the universe itself, he believed, was a living organism striving toward perfection. For centuries, this model would reign supreme, adopted by Roman scholars, Christian theologians, and medieval natural philosophers. It offered not only explanation but comfort, a cosmos with reason, structure, and moral order. But Aristotle's world, for all its life and logic, was qualitative. It lacked a system to measure and define its perfection. That task would fall to another mind, one as precise as Aristotle was expansive. Around 300 BC, in Alexandria, the lighthouse of the ancient world, another thinker was at work. His name was Euclid, and his ambition was not to describe nature, but to define the rules of space itself. Little is known of his life. He may have studied under Plato's successors and taught at the Great Library of Alexandria. But his work, The Elements, became one of humanity's most enduring creations. 13 books of proofs and propositions, distilling the essence of geometry. Euclid did not invent everything within it. He gathered and refined centuries of Greek mathematics, from Pythagoras, Theaetetus, Eudoxus, and built from them a perfect structure of reasoning. Each statement flowed from the one before, like the unfolding of a logical universe. At the heart of the elements were a few simple assumptions: points, lines, planes, and their relations. A point has no path. A line is breadthless length. All right angles are equal. And most famous of all, through a point not on a line, exactly one parallel can be drawn. From these few truths, Euclid proved hundreds of theorems, triangles, circles, solids, ratios. Each proposition followed from the last with the inevitability of fate. It was not just mathematics, it was philosophy in its purest form, truth derived from reason alone. But hidden within this method was something profound. Euclid had done more than describe shapes, he had defined space itself. His geometry revealed an infinite, unchanging, and perfectly consistent realm. A realm of pure abstraction, beyond the senses, untouched by matter or motion. Where Aristotle's world was finite, hierarchical, and full, Euclid's was infinite, homogeneous, and empty of substance, a placeless, timeless continuum. If Aristotle gave the universe meaning, Euclid gave it structure. If Aristotle's cosmos was alive, Euclid's was eternal. His geometry became the language of precision, the grammar of space and reason. To deny it was to deny logic itself. As one legend tells, when a student asked him for a shortcut to learning geometry, Euclid replied coldly, "There is no royal road to geometry." Here, then, we see two visions of the same stage. Aristotle's cosmos, a living, finite sphere, animated by purpose. Euclid's geometry, an infinite, ideal plane, ruled by necessity. One explains why things move, the other, where they move. One fills the world with meaning, the other strips it down to form. Together, they build the classical worldview, matter striving within a rational framework, a cosmos both alive and intelligible. Democritus had given us the atoms and the void. Aristotle filled that void with substance and direction. Euclid defined its shape with timeless clarity. Between them, they forged the bedrock of Western thought, a synthesis of material, purpose, and form. This foundation would endure for centuries, from medieval theology to Newtonian mechanics, until the fabric itself began to bend. But for now, in the ancient world, the stage was set. Aristotle's teleology still whispers in the life sciences, in every discussion of growth, function, and purpose. Euclid's geometry still underpins our logic, our architecture, our mathematics of space. And together, they remind us, the search for the primitive is not just about matter or number, but about the relationship between meaning and structure. In causal loop cosmology, this question will return, when we ask whether causality itself might arise from the same union of purpose and geometry. Aristotle filled the cosmos with life, Euclid measured it with reason. They shaped the stage on which every later theory would unfold. But their harmony raises new questions. Is the universe alive, or logical? Does space have purpose, or only pattern? Next time, we'll meet the thinker who tried to reconcile the two. René Descartes, who fused geometry with algebra and gave the world a new language for physics. So stay with us, as our search for the primitive continues, from elements and forms to coordinates and curves.